Uh, Welcome back to Geometry Classroom. Today we'll talk about sum of measures of interior angles of a polygon. We learn how to find this sum. In this lesson, we'll have a few objectives. First, we learn how to find this formula, because there is a formula for sum of measures of interior angles of a polygon, and how to use this formula to find missing angles, or the sum of measures of interior angles. Before getting in more details, let's recall a few things about polygons. As we know, a polygon is a closed geometric figure consisting of 3 or more sides. Yes? As we know, the most common and in the same time the first and simplest polygon is triangle, right? And we know that a triangle consists of 3 sides. Next, in increasing order of sides, is a quadrilateral, and so on. Each polygon has a certain name given by the number of sides. Now, how we determine the sum of measures of interior angles of a polygon? By identifying the number of triangles, right, that make up that polygon, right? Why? Because we know the sum of the sum of measures of interior angles of a triangle equals 180. Now, we can split or divide each polygon into 2 or more triangles. If we are able to find the number of triangles that make up that specific polygon, we will be able to find the sum of measures of interior angles of that polygon. Now, in this slide, I prepared a table with first, let's say, probably 7, probably 8 most common polygons. And we'll try to make a conjecture about the sum of interior angles of a polygon and come up with a formula. Now, first, we start with triangle, right? The triangle is the most common and the first polygon. In the third column, we write the number of sides. In the fourth column, the number of triangles. And then we come up with the sum of angle measures. Now, here, for a triangle, number of sides, we have 3 sides, right? Because any triangle consists of 3 sides. Now, number of triangles. Of course, there is only one triangle. What is the sum of interior angles of a triangle? Equals 180, right? Because we have only one triangle. Good. For a quadrilateral, yes, how we find the number of triangles that make up a quadrilateral? Look, we mark the vertices of the quadrilateral. And let's say we count, we number, right? 1, 2, 3, 4. Now, we find the number of triangles by choosing a certain vertex and then by connecting the chosen vertex with all non-consecutive vertices. Probably you'll ask, what does non-consecutive mean? We know from algebra that consecutive numbers are numbers that follow each other. Yes? For example, 1, 2, 2, 3, 3, 4 are consecutive, but not 2 and 4. Why? Because 3 is between 2 and 4, right? So we skip 3, right? So 2 and 4 are not consecutive. And we use the same idea here. As we can see, if we choose this vertex as our chosen vertex, the only vertex that is non-consecutive, yes, would be 3, right? If we connect vertices 1 and 3, right, we get the diagonal, yes? A diagonal is a segment that joins two non-consecutive vertices. For this quadrilateral, there are only 2 vertices that are non-consecutive. So, if we draw this diagonal, as we can see, this quadrilateral is divided into 2 triangles, right? Now, let's fill in the blanks here. So, number of sides is 4, and number of triangles 2, right? Because we have 2 triangles. Now, how many degrees would be here? Because we have 2 triangles, and each triangle is 180. So, the sum of interior angles of a quadrilateral would be 360, which is 2 times 180, right? Good. Let's use the same strategy for next polygons. For a pentagon, we know a pentagon has 5 sides. Again, we choose a certain vertex, let's say this one, right? And we mark as 1. Then we go clockwise and label the other vertices. So, we choose this vertex, right? We can choose any vertex, but let's choose this one. Now, what are the non-consecutive vertices for 1? Are 3 and 4, right? 2 and 5 are consecutive. Why? Because they follow 1 directly, right? So, we connect this vertex with these non-consecutive vertices, right? These are diagonals of the pentagon. Now, we get 3 triangles, right? Now, let's fill in the blanks. So, the number of sides would be 5, and the number of triangles are 3. Yeah, because the pentagon consists of 3 triangles. Now, how many degrees would be here? Would be 3 times 180, right? Which is 540 degrees. So, the sum of angle measures of the interior angles of a pentagon would be 540 degrees. Now, let's do for hexagon. For example, we choose this one, this vertex, yeah, 1, 2, 3, 4, 5, 6. Remember, a hexagon has 6 sides and 6 vertices. Now, we connect the chosen vertex with all non-consecutive vertices. And these non-consecutive vertices are 3, 4, and 5. Yes? If you connect these vertices, we get the diagonals. Now, A hexagon has 6 sides, right? And how many triangles? We count 1, 2, 3, 4 triangles. How many degrees would be in a hexagon? We simply multiply the number of triangles by 180. 4 times 180, which is 720 degrees, right? Now, we repeat the same procedure for next polygons, and as we can see, we have a pattern, right? Now, what is the number of sides of a heptagon? 7, right? Now, if you look at the relationship between number of sides and number of triangles, as we can see, the difference is always 2, right? 3 minus 1 is 2, 4 minus 2 is 2, 5 minus 3 is 2, and so on. So, if you keep the same pattern, right, here we should have 5, right? In other words, a heptagon consists of 5 triangles. Now, if you repeat the same pattern for an octagon, we're going to have 8 sides and 6 triangles. For a nonagon, we're going to have 9 sides and 7 triangles. For a decagon, we're going to have 10 sides, right, and 8 triangles. Now, as I said, the sum of interior angles of a polygon is given by the number of triangles that make up that triangle, that polygon, times 180. So, we're going to have 5 times 180, which is 900 degrees. Then, for an octagon, we're going to have 6 times 180 degrees, which is 1080 degrees. For a nonagon, we're going to have 7 times 180, which is 1260 degrees. Yes, and for a decagon, we're going to have 8 times 180 degrees, which is 1440 degrees. Yes? Now, keep in mind, if the difference between number of sides and number of triangles is 2, right? So, 3 minus 1 equals 2, 4 minus 2 is 2, 5 minus 3 is 2, and so on, yeah? So, the difference is always 2, right? Now, we can express the sum of interior angles of a polygon in terms of the number of sides now, right? How? By making a conjecture. We make this conjecture. The sum of interior angles of a polygon would be given by this formula, n minus 2 times 180 degrees. Let's say S from sum of measures of interior angles, where n would be the number of sides of the polygon. Yes? From now on, whenever you have a polygon, yes, and you want to find the sum of measures of interior angles, we simply count the number of sides and you plug it in the formula of sum of measures of interior angles of a polygon, which is this one, and find how many degrees are in that polygon. Now, how we find the measure of only one interior angle? For a regular polygon, we know all sides are the same and all angles are the same, right? If all angles are the same, if we know the sum of all angle measures of a polygon, to find the measure of one angle, we simply divide the sum of measures of interior angles by the number of angles, or by the number of sides, right? So the measure of only one interior angle would be given by the formula S over N, which is, if we replace S with the given formula, you're going to have N parentheses N minus 2 times 180 over N, or where N has the same meaning, yeah? N is number of sides of the polygon. Good. So let's have a few examples. For example, let's rewrite the formula here. S equals N minus 2 times 180. And the other one, S over N equals N minus 2 times 180 over N. Good. In the first example, it says find the sum of the interior angles of a 15 gun. What does 15 gun mean? Means a polygon that has 15 sides, right? Is a polygon with 15 sides. If this polygon has 15 sides, means N equals 15, right? Now, to find the sum, we simply use the formula for sum of measure of interior angles. So we simply plug in it. We open parentheses. Instead of N, we put 15. Then we subtract 2, we close parentheses, and then we multiply by 180. So remember, we apply PEMDAS. We estimate the parentheses first. 15 minus 2 equals 13 times 180, right? And if we multiply these numbers, you're going to have 2,340 degrees. Yes? Simple. Next, find the sum of the interior angles of a 21 gun. 21 gun is a polygon that has 21 sides. So in this case, N would be 21. So to find the sum of the interior angles of this polygon, we apply the same formula. N in this case is 21. So 21 minus 2 times 180. Again, we estimate, we evaluate the parentheses. 21 minus 2 equals 19. 19 times 180 then. And we get 3,420 degrees. Let's do two more problems with finding the measure of one angle. Look, what is the measure of each interior angle of a regular pentagon? So this time we need the measure of one angle. So It says regular pentagon. We know a pentagon has how many sides? 5 sides, right? So n would be 5. So to find the measure of one angle, we apply this formula. So you're going to have n minus 5, n minus 2, sorry, parentheses, times 180 over n, which is n is 5. We plug it in. So you're going to have 5 minus 2, right, times 180 divided by 5, which is 5 minus 2 is 3 minus times 180 over 5, which is at the end 108 degrees. So the measure of one interior angle of a pentagon is 108 degrees. And the last one, what is the measure of each interior angle of a regular 18 gun? So that this polygon has 18 sides, right? So n equals 18. Again, we apply the same formula to find the measure of one angle. So you have 18 minus 2 times 180 over 18. 18 minus 2 equals 16 times 180 over 18. Now, 180 divided by 18 is 10, right? Then we multiply 16 by 10 and we get 160 degrees. That's the measure of one interior angle for an 18 gun. So that's all we have for today. Thank you for watching my video.